Hello, this is a tutorial to solving problem 4 of homework 6 where you have four spheres located at the corners of a square and you're asked to find the effective gravitational force acting on one of the spheres due to the other three spheres. So to solve this problem, we'll start off by drawing a diagram. So we have a square here with our spheres located at the corner. So we can label them A, B, C, and D. And we're told in this problem that all these spheres have the same mass. So MA is equal to MB is equal to MC is equal to MD is equal to M. And the sides of the square, let's say, have a distance S. And so in this problem, we'd like to find the effective forces acting on square A. Right. So we know the gravitational force is given by the amplitude of the gravitational force is given by G times M1, M2 over R12 squared, where R12 is the distance between the two objects. So we'll start off by drawing a force free body diagram. So we have one force acting, which we call AC, a force acting between A and D, which we call FAD, and a force acting downwards towards B, which we call FAB. Alright, so let's start off with FAB. So FAB will be equal to, well, we'll act along so we just find the magnitudes for now, will be equal to G times M over RAB square. And in this problem, the distance between A and B is given by just the side of the triangle. So this is equal to GM square over S square. We can find FAD, so this is along the minus y direction, and we'll come back to this in a moment. Alright, so FAD is acting along the x direction, GM M divided by RAD square, and in this case RAD is also the distance between A and D, which is the side of the square, so that will be equal to S square. So along the positive x direction. And now we'll find FAC, the diagonal force, which will be equal to G times M over RAC square. And so to figure out what the distance RAC is, let's draw a triangle out square again. And we'd like to find the distance between A and C. So if this is S and this is S and this is a right angle triangle, then this diagonal here will have a magnitude of S squared plus X squared with the square root. So this will be equal to G times M squared over the square root of S squared plus S squared all square, and that will be equal to G M squared over 2 times S squared along the diagonal. Right. So now to find the resultant forces acting on A, so the magnitude of the forces acting on A are equal to the square root of the x component square plus the y component square. So we need to find what the x and y components of this resultant force are acting on object A. Alright, so to find the x component, that will be equal to the x component of FAB, so FABX, plus the x component of FACX, plus FADX. Alright, so to find FABX, FAB acts entirely along the y direction, so this component here is 0. FAC acts at a diagonal with an angle of 45 degrees. So FAC will be equal to the magnitude of FAC times the cosine of 45 degrees. And FAD acts entirely along the x direction, so FADX will be equal to just the magnitude we found for FAD. Alright, so this is equal to FAC is given by GM squared over 2 times S squared, and the cosine of 45 degrees is 1 over the square root of 2 plus FAD, which is GM squared over S squared. So this simplifies to become GM squared over S squared multiplied by 1 plus 1 over 2 square root of 2. Alright, so now we have to find FAY. So let's put a divider here. So FAY will be equal to, again, the y components of the different forces. So in this case, FAB acts in the negative y direction, so we'll have a negative sign here, and FAB has a magnitude of GM squared over S squared, and also FAC has a component acting also in the negative y direction, so there'll be a minus sign here times GM squared. So just like we have the cosine of 45 degrees, we'll be having the sine of 45 degrees, which is also 1 over the square root of 2. So this gives us the magnitude of, or the component FAY being GM squared over S squared, 1 plus 1 over 2 square root of 2. Alright, so to find FA, magnitude FA, we have to take the square root of the FAX component, so this here, and the square root of the y component, which we have here. So let's extend this out, GM squared over S squared, 1 plus 2, 1 over 2 square root of 2 all squared. So that gives us the magnitude of A, and to find the angle, that would be equal to the tan inverse of the y component of y of A divided by the x component of A.